All right, lesson 8 today. Now, lesson 6, module 1, geometry. We began our discussion on solving for unknown angles, and the concept, the big picture is we want to look for relationships through our vocabulary that allow us to set up equations that then allow us to solve using our algebra and solve for unknown angles. In lesson 6, we began to look at 3 concepts: supplementary angles, vertical angles, and then the sum of angles around a point equal 360. In lesson 7, we dealt with this concept of 2 parallel lines, 2 or more parallel lines cut by a transversal. And we learned things like corresponding angles, what are alternate interior angles, alternate exterior angles, as well as same side interior angles are supplementary. And so today we extend this, but we're going to focus more on the justification of these equations, not just solving. And so let's start with the student outcome. Students, you're going to review formally, learn geometry facts, some that I just mentioned, and we're going to practice citing. This is key. We're going to practice citing the geometric justifications regarding angles in a triangle in anticipation of unknown angle proofs coming up here in the future. All right, let's start with the discussion here, and a little review here. In the previous lesson, we learned this concept of drawing an auxiliary line, and you'll notice here they give you a picture and they want you to solve for x. Well, we learned, as it's described here, that an auxiliary line is a line that we can draw that helps us use and break 72 into parts. Considering these are parallel lines here and here, we know that this angle and this angle are corresponding. And so, since they're corresponding, then of course they're equal. And that allows us to know that this is 35. And if the whole thing is 72, then that allows us to solve for this part right here. So you can see the description. This is a good review from lesson 7. It's a good little review on auxiliary lines and how we use them. So I would advise you to read that over. It's in your packet, and it's a good start for this lesson. Review of auxiliary lines. All right, so let's discuss a couple things. One thing is, let's review the fact that the sum of 3 angle measures of any triangle is always 180 degrees. A point lies in the interior of a triangle if it lies basically inside the triangle. In any triangle, the measures of the exterior angle is equal to the sum of the measures of the, and I'm going to go ahead and use the sort of the basic terminology, the opposite interior angles. What we mean by that is the following. If we have a triangle like this, and we know that this is X, and we'll call this Y and Z, these 2 angles are the opposite interior angles, whereas this is the exterior angle. X is going to be equal to Y plus Z, the sum of the opposite interior angles, otherwise known as remote interior. And that's what you're going to hear me call them, remote interior angles. That's a big concept that we're going to use today. We, of course, should be familiar that base angles of an isosceles triangle are equal in measure. We should also know that each angle of an equilateral triangle has the measure of 60 degrees. So those are things that we should probably know. So that brings us to some more, and again, we just sort of reviewed isosceles triangle. angles in a triangle, as well as exterior of a triangle here. So there's some key words for this lesson. Let's now see if we can use that in looking at example number 1. So let's do this together. Notice that we are trying to locate and find B and A. Now right away, I'm focusing in on A because I see that I have a triangle, and inside this triangle, I know that 69 plus 58 plus A, I know that the sum of the interior angles in a triangle equals 180. The sum of the interior angles in a triangle. And so we have 69, 58, and A. I know they equal 180. And so one of the things that I'm going to do is I'm going to go ahead and solve for A, and I'll do that right now. And it's always good to have a calculator to make things easy. So I'm going to use my trusted calculator, just as I would suggest you have a calculator always. 69 plus 58. And now we're going to review our algebra. And this is what I would expect to see from your paper. Showing your good algebra skills and solving for A. Slow the video down if I go too fast. That's the great thing about the video lessons. You can pause them, rewind it, and A is equal to 53. And that is an A, not a 9. That's an A. And so, before somebody gets messed up there, go ahead and rewrite that as an A. A is 53. Okay, so far we have A. Now, how do we find B? How do we find B? Well, I notice if I trace this, now that I know this is 53, I notice that, well, here's a triangle, and here's the exterior angle. Well, look, didn't we just talk about this earlier? We know that this angle is related to these two angles. Yep. Angle B and angle A are remote interior angles to 93. And so that allows us to set up an equation. So I'll do that right here. B plus 53 now, that's what A is equal to 93. Solve. And B is equal to 40. So that gives you a chance to look at two examples. Oops, sorry about that. I forgot to write that. Two examples of using our relationships that we've learned to solve for missing angles. Okay, again, stop it, rewind it, pause it, whatever. Okay, we're going to do one. We're going to do maybe two more. Try to do two more. Okay, here we go. Two more. This one's straightforward. This one is very simple because you notice that, hey, I think I've seen this one before. Here's a triangle. This is an exterior angle. These are the remote interior angles. So the equation, A plus 42 is equal to 78. Solve. And A is equal to 36. It did want us to give the reasons here. And so the reason that I'll be stating is exterior angle is equal to the remote interior angles. Now I'm going to abbreviate, but that's the reason right there. That's the reason. And finally, the last problem. Again, we want to determine the measure of the unknown and then also give our reason. So let's take a look at number 3. The first thing I notice here is It looks to be an isosceles triangle. Yep, it's an isosceles triangle. So that means I know this is 68. That's 68 degrees. Now, in order to find B, I really need to find this angle right here. Oh, wait a minute. I don't need to, because once again, the same reason I can use here. This is an exterior angle. It should be equal to those two. So in this one, I could actually do a couple different things, but this is probably the easiest still. 68 plus 68 is equal to B. And so we get the answer of B is equal to 6, and 136 is our answer. 68 plus 68, and the reason is because exterior angles are equal to the remote interior angles. So again, you're going to be tested today, or at least challenged with the idea of solving for unknown angles, and then also really focus on giving the reasons for that. Okay, for right now, that'll do for lesson 8, and we'll go to our practice. Good luck.